Let's work on an example using the epsilon delta definition to prove the limit of a function. So for this case, the function is 5x minus 4. So we evaluate we want to show that the limit of 5x minus 4 as x approaches 2 is indeed equal to 6 using the epsilon delta definition. So let's recall the epsilon delta definition. It just says that the limit of f of x as x approaches a is equal to L if this condition is satisfied. So what does this condition mean? This condition just tells us that for any value of epsilon that we pick, for any epsilon greater than 0, it's arbitrary, so we can pick any value. If we are able to find a delta greater than 0 such that this condition is satisfied, then this is true. Now, what does this condition mean? This condition simply says that if x is in the interval a minus delta to a plus delta, then f of x must be, or it follows that f of x should be within the interval L minus epsilon to L plus epsilon. So for this example, we can see that our A is equal to 2 and L is equal to 6. So for any epsilon that we can find, we have to look for a delta such that this condition is satisfied. So we will work on this algebraically. So we want to get a delta such that f of x minus 6, the absolute value of f of x minus 6 is less than epsilon. So f of x is this function. So we just substitute that to f of x and we'll proceed to work on it algebraically. So if you look at this, we use the properties of absolute value to end up with the inequality, the absolute value of x minus 2 less than epsilon over 5. So if you look at this, this is x minus a. The value of a is 2, so this is x minus a less than, this must be less than epsilon over 5. So this must be our delta in order for us to get this. So again, what we found earlier means that for the absolute value of f of x minus 6 to be less than epsilon, then our delta must be epsilon over 5. So let's look at it graphically. This is the graph of 5x minus 4. And then let's plot x equal to 2 or a, and then L, which is equal to 6, which we claim to be 6. And then we pick any value for epsilon. So for this case, since it's arbitrary, I can pick any value for epsilon. So let's suppose this distance here holds the value for epsilon. So we have, this is epsilon, the distance between this. So meaning, for that value of epsilon that we pick, you don't have to pick a specific value because since it's arbitrary, we can pick any value. So for any epsilon, we are able to produce an interval from 6 minus epsilon to 6 plus epsilon. And then if you look at this, 6 minus epsilon would have a corresponding point on the graph with a coordinate, let's say x sub 1, 6 minus epsilon. Similarly, 6 plus epsilon would also have a corresponding point on the graph with the coordinate, let's say x sub 2 and 6 plus epsilon. Okay, now we have an epsilon. What we need to look for is a value for delta such that if we pick an x within 2 minus delta to 2 plus delta, the corresponding value of that x or the corresponding point of that x on the number line would be within this range. Would be within 6 minus epsilon to 6 plus epsilon. Okay, so the widest interval for x minus for 2 minus delta to 2 plus delta would be, the left endpoint would be x sub 1 and the right endpoint would be x sub 2. This is the widest that we can find because this is the one that defines or that corresponds to the interval 6 minus epsilon to 6 plus epsilon. So let's look for the value of x sub 1 and x sub 2 in terms of epsilon. Okay, so why do we have this? 6 minus epsilon is the, okay, our function is 5x minus 4. So we substitute x sub 1 to 5x minus 4. It should get a corresponding y value of 6 minus epsilon because that's the point on the graph. So that's why we have this, and then we do some algebra, and then which gives us x sub 1 equals 2 minus epsilon over 5. So we have that for x sub 1. Now we look for the value, or we solve for the value of x sub 2. X sub 2 corresponds to the y value 6 plus epsilon. So we do some algebra, and we find a value for x sub 2 to be 2 plus epsilon over 5. Okay, so these are the endpoints. So our delta must have a distance. Okay, so we pick x values within the distance of 2 minus delta to 2 plus delta. So since this is the since x sub 1 and x sub 2 would be the widest endpoints of the interval, then we can pick, okay, look at this. The interval must be from 2 minus delta to 2 plus delta. So we can pick any value for x within this interval. Okay. So the widest, the biggest interval or the widest interval that would satisfy the condition would be to have 2 minus delta equal to x sub 1 and 2 plus delta equal to x sub 2. So meaning the delta would be, we can have delta to be the minimum between the distance from 2 to 2 minus, right? Delta is the distance from 2 to 2 minus delta, or 2 to 2 plus delta. So meaning we can take delta to have the value or the distance, the minimum distance between 2 and x sub 1 or 2 and x sub 2. So we just substitute. This is x sub 1. This is x sub 2. Whatever the minimum is, that's what we give for delta. So if we simplify this, we will get epsilon over 5. The values for each of these is epsilon over 5. So therefore, our delta must be epsilon over 5. So we take epsilon over 5. Then we will show that indeed this value for delta would satisfy the condition. So we go back to having f of x, the distance between f of x and 6, or the absolute value of f of x minus 6. With this value for delta, we should end up having this to be less than epsilon. Okay, so let's continue with this algebraically. So this is less than delta, right? And our delta is epsilon over 5. So we substitute. Okay, so this is f of x, the absolute value of f of x minus 6 is equal to 5 times the absolute value of x minus 2. Now, since the absolute value of x minus 2 is less than delta, then we can write this as less than 5 times delta. Why did I substitute epsilon over 5? Because delta is epsilon over 5. If we cancel 5, we get epsilon. So indeed, the absolute value of 5 of f of x minus 6 is less than epsilon. So therefore, the limit of f of x minus 4 as x approaches 2 is equal to 6.